Good morning. This is Professor Gardetto. We are going to be working through more quadratic equations today. Hopefully, you watched the last mini video and the lecture on um, factoring to solve quadratic equations. Today, we're going to go over a couple of different methods other than factoring because no quadratic equations can be solved. Sometimes they aren't factorable. Specifically, we're going to look at homework number 17 and um, start the assignment here. Okay, so we last week talked about square roots, and like say we had the square root of 9. If we have a square root of 9, I told you that all we do is we find a number that is the same number that multiplies to get 9, so that answer is 3. However, when we have an equation that's a quadratic equation, I'm just going to rewrite this one over here. We have a squared equals 9. We're going to use something called the square root property. Okay, and the square root property basically says if you have a square, you can get rid of a square by taking the square root of both sides. However, there's one other thing you need to do. After canceling the square and the square root, you're just left with the variable. On the right-hand side, though, we need to take the positive and the negative square root of 9. So just like the square root of 9 is 3, we have to have two solutions. Remember yesterday whenever you watched the mini video, we talked about quadratic equations having two solutions. If you don't put the plus or minus sign down, you're only going to get one solution. This should kind of make sense when you plug it back in. We know that 3 squared is equal to 9, but also negative 3 squared is equal to 9 because negative 3 times negative 3 is equal to 9. So when we put our solution set in, you're going to see a little plus or minus sign. Let me erase this. Okay, so see this little plus or minus sign here? So we can click this because your keyboard doesn't have a plus and a minus on top of each other. So I'm going to click this first, makes the plus or minus, and then we hit 3. And then we check our answer. Okay. Now, not all numbers have square roots. Before you apply the square root property, which if I wrote out what the square root property is, the square root property basically is if this is the square root property in general, if x squared equals a, then x equals the positive and the negative square root of a. And sometimes we're able to take the square root of the number, like 9, and other times we can't take the square root of the number. We have to simplify it. We don't ever want to go into decimals. We want to write the answer in simplest form. It says here, write imaginary solutions in the form a plus or minus bi. You should know how to do that from last week. But before we apply the square root property, we need to isolate the squared term. So in this case, it says a squared minus 7. So I'm going to just add 7 to both sides, just like you're isolating any other variable. And then you apply the square root property. Once you have the square isolated, you take the square root of both sides. The square goes away, the square root goes away, and then you have to remember to put the plus minus sign. Always remember to put the plus minus sign. And we can't take the square root of 7. We can't simplify the square root of 7. So we just leave it as plus or minus square root 7. Again, you're going to see the plus or minus sign. You'll see the plus or minus sign, which is probably the first thing you want to hit. Then you have the square root, and then you just put in 7. And that's all there is to it. Okay. Why do we need to use the square root property? Well, these binomials aren't factorable. They aren't able to be factored. And when you have a quadratic equation that's not factorable, your answers are irrational, which just means that your answers are going to contain a square root of a number that we don't know. If you had a factorable quadratic, if you have a factorable quadratic, like say we have a squared minus 9 equals 0, well, that's factorable. That's factorable. That's a plus 3, a minus 3. Right? Remember the box method? If we put a plus 3, a minus 3, the minus 3a and the plus 3a would cancel. So by the zero product property, like we talked about yesterday, a is equal to negative 3 or a is equal to positive 3. So since this is factorable, your answers are integers or rational numbers. Sometimes they're fractions. We found out yesterday sometimes the answers are fractions. We could have solved this problem another way. We could have just isolated the squared term. So we add 9 to both sides. Took the square root by the square root property. We take the square root of both sides. And we put plus or minus square root of 9, which is plus or minus 3. These are the same two answers. The only way I could, the reason why I'm showing you it solved twice is this is how we solved them yesterday. We solved the quadratic equations by factoring yesterday um, in homework 16. Homework 17, you're going to not be able to factor some of them. Actually, most of them aren't going to be factorable. So we have to have some other methods. So the square root property is designed to give you these solutions the same way factoring gives you the solutions. So let's see, number 4. We're going to go over number 4. Okay, so now we have to isolate the square again. We have a 64u squared, so I have to divide both sides by 64. Now, before you take your calculator out and divide 169 by 64, because that possibly is going to give you some decimal. Think about when you take the square root of 169 and you take the square root of 64. If you can take the square root of the top and the square root of the bottom, don't do the division. Okay, because the answer is going to be rational. The square root of 169 is 13. And the square root of 64 is 8. So we get plus or minus 13 over 8. There's no square root sign in our answer here. Okay. And you don't want to write this as a decimal. You don't want to write this as a mixed number. You want to leave it as a fraction. And there will be a fraction tool over here. Also the plus minus sign. The plus minus sign will always pop up when you put this when you click in the box. The plus minus sign is right there. You're going to have to use that because there's no plus minus sign on your keyboard. Okay. Number 6. Okay, so number 6 here, we are going to, let's see, have to get rid of the negative 3. I'm going to divide both sides by negative 3. So I have v squared equals, that's 27 divided by negative 3 is a negative 9. So square root both sides here, we have a problem. We cannot take the square root of a negative number without going into imaginary numbers. So that's why it says right here in the directions, write imaginary solutions in the form a plus bi. In this case, there's no a, but there is something that you always have to remember. It's plus or minus. Plus or minus. And then remember the negative comes out as an I. The negative comes out as an I. And then you take the square root of 9 and put 3. It's common practice to put the number in front of the I value. Okay, remember the square root of -1 is equal to I from last week. And so we pop that number in our answer. You have imaginary solutions here. 7. Okay. So 7 has something in the parentheses, but the squared term is isolated. It's just instead of h squared, it's h minus 6 squared. So we can go straight to the square root property. We can go straight to the square root property. We take the square root of both sides. So now you just have h minus 6. I'll just drop the parentheses. You don't really need them anymore. But you do have to remember, and this is something that you're going to forget, the first thing you want to write down is plus or minus, and then take the square root of 9. You're going to look at the square root of 9, you're going to think 3, which is good. But you have to remember it's plus or minus 3. Plus or minus 3. So now you're not done yet. You still have to get rid of this minus 6, so we have to add 6 to both sides. You have to add 6 to both sides. So where are your two solutions? Well, your two solutions are using the plus 3. It's 3 plus 6. Well, 3 plus 6 is 9. And then we use the minus 3. Minus 3 plus 6. Minus 3 plus 6 is 3. So we have two answers here. We don't want to write your answer. You don't want to write your answer like this if it can be simplified further. And it can be simplified further here because we know what 3 plus 6 is and we know what negative 3 plus 6 is. Nine. Okay. All right. 9 is, let's see, similar to 7, except for now we have this minus 7 that we have to get rid of. Always isolate the radical first. So if we just add 7 to both sides, that 0 becomes a 7. And now we can go ahead and take the square root of both sides. So we have 5p minus 3 equals, what do you have to remember to do? That's right. You have to remember to put the plus or minus sign in. And now we don't know what the square root of 7 is. So I'm just going to leave it as the square root of 7. Okay, so now there's two things we need to do. We need to get rid of this minus 3, and we have to get rid of the 5. I'm going to get rid of the minus 3 first. So I'm going to add 3 to both sides. When I add 3 to this, it's common practice to put the 3 in front. So we have 3 plus or minus square root 7. And then you have the 5p. It's not wrong to put the plus 3 over after the square root 7. It's just common practice to put the 3 plus or minus. It's kind of in this form here. So, and then we have to divide by 5. So this is our answer. 3 plus or minus square root 7 over 5. How do we pop that in here? Well, if you click the box, it does give you a fraction tool. So I'm going to hit the fraction thing first. It gives me the fraction. I'm going to type the number 3 in on my keyboard, plus or minus sign. Then you have the square root key, not on my keyboard, but the square root key over here on the screen, 7. Then click the bottom box and put 5. Okay. Okay, and 11 will be the last problem that talks about the square root property. Okay, so this is a problem that, well, let's see, we want to isolate this squared term. Okay, always try to isolate the squared term first. So we had to add 2, and we have to divide by 7. So I think I can do that in my head here. That's going to be h squared equals, if I add 2, that's 5. And if I divide by 7, I get 5 over 7. Okay, it's 5 divided by 7. It's not something we don't want to put as a decimal. We're going to leave it as a fraction. So we're going to take the square root of both sides. What do you have to remember? Yes, you have to remember the plus minus sign. Always remember the plus minus sign. Now, this one here, you can't take the square root of 5. You can't take the square root of 7. You can't take the square root of 5, but I'm going to go ahead and put the square root of 5. You can't take the square root of 7, but I'm going to go ahead and put the square root of 7. And it's really not allowed to be like this because this is not in simplest form. Do you guys remember how to get that radical away from the denominator? It's called rationalizing the denominator. Remember the big fat 1 from last week? The big fat 1. I'm drawing the big fat 1 again. Here we go. Here's the big fat 1. I'm going to multiply both the top and the bottom because of this radical here in the denominator that's not allowed. I'm going to multiply it by the square root 7 over the square root 7. Why square root 7? Well, if you multiply a square root 7 times the square root 7, you get 7. The plus minus sign comes into your answer. And now you multiply 5 times 7 and you get 35. You got to be careful to bring a number out if it can be simplified. 35 can't be simplified. It's only 5 times 7. 5 and 7, or 1 and 35, neither, they aren't perfect squares. So we can just leave our answer like this. Okay, just make sure, do not leave your answer like this because of the square root in the bottom. Okay, so that is the square root property problems. So the second part of this homework is about something called completing the square. So you'll be starting off by being asked what value, it's a two-part question, what value of n will be your last number, can you put in so that this is a perfect square trinomial? Okay, so there's a process to find this number, and it's always the same. Here's the process. You take this number here, you take that number that's in front of the middle term, the x value, you take half of it. You take half of it. That means you divide it by 2. And then you square it. There's 2 steps. You take half of it, and then you square it. Well, take 10 divided by 2, and you get 5. And then if you take 5 and square it, you get 25. That's the number that n has to be. N has to be 25. That's what you put in here. 25. Sometimes it'll be a whole number. Sometimes it'll be a fraction. This is a two-part problem, so they're going to want you to check your answer before. And then you're going to want to factor the trinomial. Now, if it's a perfect square trinomial, which it is, it's always going to be a perfect square trinomial. When you factor it, it's going to be factored into 2 of the same sets of parentheses. It's going to be x and x plus and plus, and then 2 numbers are multiplied to get 25 and add to get 10. You get it as 5 times 5. So when you write this, when you click here, you can write x plus 5, but I'm going to go ahead and put x plus 5, and I'm going to use the exponent key and write it as a square. Okay, this next way of solving quadratics is by doing something called completing the square. And even though you could write it as x plus 5 and x plus 5 again, it's easier when we get to the method completing the square as writing it as a square. Okay, So I'm going to check my answer here. Should be a green check mark, and then clear my screen. Okay, let's go over 15. Okay. All right, so here's the same process. Find the value of n so the expression is a perfect square trinomial. Okay, so we take half of the middle number and square it. Now, do not go into decimals. Okay, 9 divided by 2 is 4.5, but I'm going to leave it as 9 divided by 2, and I'm going to square it. So if I square 9 divided by 2, I get 9 times 9, so that's 81. And 81, 2 squared, it's 81 over 4. So you want to write it as integers or fractions. Integers are whole numbers, fractions are fractions. Notice there's no decimals. Okay? Don't go into decimals. 81 over 4. 81 over 4, when we click this, there's a little fraction bar right there. We're at 81 on top. We write 4 on the bottom. Okay, check our answer. And then part two has you factor. Now, we haven't done too much factoring with a fraction constant term, okay, but it's really not too difficult. Remember, it's going to be the same thing. It's going to be the same thing. It's going to be A and A. It's got to be plus and plus. Okay, and now just think of it, two numbers that multiply to get 81 over 4. Well, it's this number right here. It's this number right here. It's 9 over 2. 9 over 2 times 9 over 2 is 81 over 4. And 9 over 2 plus 9 over 2, remember when you add fractions, you just add the numerators if the denominator is the same. What do we get when we add 9 plus 9? 9 plus 9 is 18. 18 divided by 2 is equal to 9. So don't do any hard thinking here. When you see the fraction here, this only happens when this number's odd, by the way. When you have an odd number in the middle, you'll have a fraction constant. But it's whatever this number in the middle is divided by 2 will be your fraction answer. So when you type this in, you can type it in as you can just use the parentheses, A plus, and then you can use this fraction tool here, and it's going to make the 9, or you can type in the 9, but it'll make the fraction. 9 over 2 in your parentheses, and then make sure to put the squared term. Okay. Okay. The next problem I want to go over is 19. 19. Oh, my thing froze up on me. Okay, that's okay. I'll just close it down and start it up again. I remember what problem I'm on. Preview. That was 19. That was 19. 23. Okay, so here's the whole reason why we've been doing that completing the square business. This quadratic equation, if we try to solve it by factoring, I don't believe this is factorable. It says solve the equation by completing the square, but let me show you why we need another method. Okay, if I go p squared minus 8p And if I add 21 to both sides because I want to make it equal to 0, because that's how to solve quadratic equations, by factoring, I would get stuck here in this problem, because when I did the diamond problem and I put 21 on the top and I put -8 on the bottom, there are no numbers that multiply to get 21 that add to get -8. And 21 is 3 times 7, so I can get -10. If I make one -3 and one -7, I can get -10, but I can't get -8. So this is not solvable by factoring. Okay, meaning your answers are not going to be whole numbers or fractions. Your answers are going to be irrational. Okay, so this is how to solve it by a method called completing the square. Okay, I abbreviate this CTS, and I'm going to go over a lot more examples than just one on lecture today. So I'm only going to show you one on this mini video because I like to keep them short. So here's how to solve it by completing the square. Okay, notice I'm just rewriting the problem, but I'm going to leave a space right here in between that -8p and the equal sign. I'm going to copy the -21 down, and I'm going to leave a space right there. Okay, 2 spaces, one on the left, one on the right. What's going to go inside the spaces? What's going to go on the spaces is the completing the square. So I'm going to take half of this number. Forget about the negative. Doesn't really matter because you're going to square it anyways. I'm going to take half of this number and I'm going to square it. I'm going to take half of 8 and I'm going to square it. Half of 8 is 4. 4 squared is 16. So I'm going to add 16 on the left-hand side. Now, if I want to keep the equation true, I can't do something on the left side without doing the exact same thing on the right side. So I'm going to also add 16 to the right-hand side. Okay? Now, what I've in fact done is I've made a perfect square trinomial. This right here can be factored into 2 of the same binomial. I'm not going to write 2 of the same, though. I'm going to write it once. It's p minus, because of the minus right here, and then 2 numbers to multiply to get 16 that add to get -8 is 4. And I could write it as a square. P minus 4 squared is the same as p squared minus 8p plus 16. I factored it. -21 plus 16 is -5. Okay, now I have something squared. Now I can apply the square root property. I can square root both sides because I have something squared. The square and the square root are going to go away on the left-hand side. I'm just going to have p minus 4. What do you have to remember when you have a square root on the right-hand side? Yes, that's right, plus or minus. And now I have the square root of a negative, so an I is going to come out. And I can't take the square root of 5, so I'm just going to leave it as the square root of 5. So this is going to be an imaginary solution. There's one last step here. I need to get this 4 over on this other side. So when I add 4, it's customary to just put the 4 in front. So you notice the form a plus or minus bi. So it's 4 plus or minus I root 5. 4 plus or minus I root 5. I believe the box here, we could put the 4. We could put the plus or minus. There's the I. And then I put the square root of 5. So I need to hit the square root key. And then 5. So 4 plus or minus I root 5. And that's the last couple problems, 23 and 24, actually 22, 23, 24. I think those are, yep, the last three problems are going to have you solved by using completing the square. I'll be going over way more of those problems during lecture today. Otherwise, you should be able to work through some problems on homework 17. Bye.